Billions of years ago, before the proliferation of large cities and industry, nature's own systems kept the air fairly clean. Wind mixed and dispersed the gases. Rain washed the dust and other easily dissolved substances to the ground, and plants absorbed carbon dioxide and replaced it with oxygen. The troposphere and stratosphere are two layers of the atmosphere. The troposphere, which supports life on Earth, is the atmospheric layer close to the Earth's surface. This layer extends only about 17 kilometers above sea level over the equator and 6 kilometers above sea level over the poles. The second layer, which is the stratosphere, extends about 17 to about 48 kilometers above the Earth's surface. Although the stratosphere contains less matter than the troposphere, its composition is similar, with two notable exceptions. Its volume of water vapor is about 1/1000 that of the troposphere, and its concentration of ozone is much higher. Much of the atmosphere's small amount of ozone is concentrated in the portion of the stratosphere called the ozone layer, found roughly 17 to 26 kilometers above sea level. Most stratospheric ozone is produced when some of the oxygen molecules in this layer interact with ultraviolet radiation emitted by the sun. This global sunscreen of ozone in the stratosphere keeps about 95% of the sun's harmful UV radiation from reaching the Earth's surface. But now, with increasing urbanization and industrialization, humans started to release more waste into the atmosphere than nature could cope with. Since then, more pollution has been added to the air by industrial, commercial, and domestic sources. As these sources are usually found in major cities, the gases that are produced are usually concentrated in the air around them. Air pollution is the presence of chemicals in the atmosphere in concentrations high enough to harm organisms, ecosystems, or human-made materials, or to alter climate. It usually comes from natural and human sources. Three major outdoor air pollution problems are industrial smog, primarily from burning coal, photochemical smog from motor vehicle and industrial emissions, and acid deposition from coal burning and motor vehicle exhaust. Scientists classify outdoor air pollutants into two categories. The first one is primary pollutants. These are chemicals or substances emitted directly into the air from natural processes and human activities at concentrations high enough to cause harm. While in the atmosphere, some primary pollutants react with one another and with other natural components of air to form new harmful chemicals called secondary pollutants. There are several major outer air pollutants. One is carbon oxides. Carbon monoxide is a colorless, odorless, and highly toxic gas that forms during the incomplete combustion of carbon-containing materials. Carbon oxide can combine with hemoglobin in red blood cells, which reduce the ability of blood to transport oxygen to body cells and tissues. Long-term exposure can trigger heart attacks and aggravate lung diseases such as asthma and emphysema. The second major outer air pollutant are nitrogen oxides and nitric acid. Nitric acid is also a colorless gas that forms when nitrogen and oxygen gas react under high combustion temperatures in automobile engines and coal-burning power in industrial plants. Both nitric oxide and nitrogen dioxide play a role in the formation of photochemical smog, a mixture of pollutants formed under the influence of sunlight in cities with heavy traffic. Other major outer air pollutants are sulfur dioxide and sulfuric acid, a colorless gas with an irritating odor. Particulates or suspended particulate matter consists of a variety of solid particles and liquid droplets that are small and light enough to remain suspended in the air for long periods. Ozone, a colorless and highly reactive gas, is a major ingredient of photochemical smog. It can cause coughing and breathing problems, aggravate lung and heart diseases, reduce resistance to cold and pneumonia, and irritate the eyes, nose, and throat. Volatile organic compounds, or VOCs, organic compounds that exist as gases in the atmosphere or that evaporate from sources on Earth into the atmosphere, are called volatile or volatile organic compounds, or VOCs. Burning coal produces industrial smog. Industrial smog consists mostly of an unhealthy mix of sulfur dioxide, suspended droplets of sulfuric acid, and a variety of suspended solid particles in outside air. Sunlight plus cars equals photochemical smog. A photochemical reaction is any chemical reaction activated by light. The formation of photochemical smog begins when exhaust from morning commuter traffic releases large amounts of nitric oxide and volatile organic compounds into the air over a city. When dealing with air pollution, legal, economic, and technological tools can help us to clean up air pollution, but the best solution is to prevent it. We can apply laws and regulations. We can also use the marketplace. And reduce indoor air pollution should also be a priority. And by that, we can now emphasize pollution prevention.